research on vulnerabilities, malware, protocol analysis, evolution of attack vectors, and signature development for network and host-based IDS, IPS products. So the paper title is Inception of Graphical Passwords, the thing that you can possibly see from this figure, that you're connecting dots, something that's your password. Maybe more details, further details will be revealed by Mr. Rishi himself. So in the past, he has served as senior consultant at Deloitte and security researcher with Trend Micro. Among his key public disclosures, he has been responsible for LinkedIn vulnerability and first Google Chrome exploit. That's good. He has been quoted in Reuters, Forbes, and many other mainstream media. He has been an author with advisor of Hack9 magazine and Pentest magazine. He has been also involved as a contributor to international pen testing standards as well. In the past, he has been a speaker at OWASP, Bangalore Cybersecurity Summit, and e-Surakshit conferences. In this free time, he prefers reading blogs, scripting, Twitter, and writing articles for his personal blogging. So I welcome you here, and I hope you'll enjoy his presentation. Thank you.
Thank you. Okay, I heard there is no tea outside. Is that so? Everybody well awake, right? Come on, say yes.
Yeah.
Stop the mic. Okay, so the reason I jumped to graphical passwords is primarily because most of the touchscreen-based devices, it's very tedious to type in the password, especially we all security paranoids. So we have long passwords, 16 characters, maybe 20 characters, which includes symbols, which includes alphanumeric. So I thought that let's bring in some graphical passwords where you just have to connect the dots and you're done. Who am I? It's pretty much done. So I'll just skip this. So agenda. So what's already out there? The beast, the slayer, and then there are the lambs. Touchscreen device, issues with the conventional wisdom of passwords, what we know about the passwords till date. What made me call this Eureka movement? The demo, code level walkthrough. So I'll actually release it public. Post this, I'll put the code on my blog. Anybody can download, get their creativity into it, can use it on their web applications. It's all free of cost. Cons, there are some not so good points about graphical passwords and the roadmap, so which I'll be personally developing for the future. And I'll welcome web developers to be a part of it. Okay, so what's already out there? 72%. What's this figure? It's actually the percentage of people who have forgotten one of their password at least once in last 6 months. And including me, I'm no different than the 72% because there are social networking sites, there are bank sites, there are blogs, there are mailing lists, there are email accounts. I have like 20 odd accounts and I never keep same password. So I have to remember 20 passwords. I don't use password managers. I somehow don't like that. And I have different operating systems, Linux, Mac, Windows, my Touch, my BlackBerry, my Android. So that's practically not possible to use password managers. So I have to remember 20 passwords, plus all the password complexities range more than 8 to 10 characters with spatial symbols. So think how much I have to remember. And the reason last 28% are not there because I assume they have guessable passwords, which is my dad 123, my mom 123, or my name, or they have penned down somewhere under the keyboard so they never forget that, or have shared with someone. So like some time back, my dad actually shared the password with me. So every time he forgets, he just calls me, like, what's my password? Or the best case scenario, they eat a lot of aliments. They have good memory, which I don't, but let's assume so. So this is some password security facts. So do you have a complex password? And do you have passwords with length more than? So how many of you have passwords length more than 10 characters? Okay. How many of you have 10 different passwords to memorize? More than 5? Okay. People are very less active on the internet. Okay. So these days, to prevent brute force logical guesses, people are getting paranoid with passwords. So there's some password example. This I had like 2 years back. This was the password. So it's crazy. So anybody can think of why I had this password? It makes sense to anyone? Okay. So this is LOL. This is SAMOSA, samosa. So this was LOL samosa at sin hash. That's it. So which made some sense to me, but after that I forgot it was kachori, samosa, or roti. So this thing happens usually. So forgetfulness is directly proportional to complexity. The more complex the password, definitely sure I'll forget it at some point of time. So some issues with the conventional wisdom of passwords. What we have seen so far in real web application in context of typing. So I'm not going into hacking right now. It's just how tedious it is to type. It's alphanumeric plus symbols as password. People keep that. People use on-screen keyboard for banks or for their touchscreen devices, but still alphanumeric and symbols. There's nothing new in it. There are some picture seals. So Yahoo and some bank accounts use, but it is for phishing. It's to prevent phishing. That's it. So once you see your seal on top of it, it means you are on the right page, but it has nothing to do with the passwords. And then there's picture selection password, which is now coming with as a two-factor authentication with some banks, not all the banks, but some banks give you some 10, 15 pictures. You have to select 1 or 2 pictures out of it, and next time it will throw you some random set of pictures. You again select the boat or the whatever XYZ things. So these are the kind of authentication measures which are going on. So what are the issues with it? So we have all the passwords when it is related to alphanumeric or let's say alphabets, they are mostly words and phrases. And we heard words and phrases all around us all the time, 24/7. So at the end, if I have to think of a password, what was my password? I'll have, I don't know, the same thing, samosa, roti, kachori, I don't know. So many communicative words and phrases all around us makes a password difficult to remember. So either you make a symphony or perish clicking forget password every time. Passwords can be logically guessed if you know the person well. So let's say I know my friend well, I know he's not going to keep long passwords. It's either going to be his name, his date of birth, somewhat his personal detail. So there's some logical guesses possible when it comes to alphanumeric passwords. And passwords can be grabbed by man in the middle for different parameters and perhaps replayed straightforward. So let's say I am running a sniffer on a network or I am tapping the line. I always check for username variable and password variable. I get the password and I'm 100% sure it's actual password. So next time if I want to replay that password, it's going to match. There's no ways that it could be stopped on the server side. So these are the issues with the conventional passwords which we use till date. And if all is fine, it's a pain to type the password on a touchscreen device. So I'll rotate the touchscreen device. I have this in between the presentation once the demo is going on. So everybody can try their hands on the graphical passwords. I'll just rotate it. You can see how it's easy to type and how it's easy to actually draw rather than to type it. So given a choice, which is easy to remember? A picture or a pattern versus a random alphanumeric strings with symbols. So at the end of the day, or if 2 days down the line, I show you this and I ask you this, will you remember that or will you remember this? Answer?
Picture.
Okay, everyone is awake. So what made me call Eureka? And most of the tools I have previously developed, it's only my weekend projects. I just get a click, I just get a blink, and I just do it. So steering ideas before the Eureka call. So on-screen keyboard makes sense with touchscreen devices. So you need not to have hardware keyboard with you all the time. So in future, when all your devices are going to be touchscreen, most of you would be knowing that laptops are also coming with touchscreen. Lenovo, I think hybrid laptops are coming with touchscreen. So yes, it makes sense to have on-screen keyboard. If gestures are fundamentally inherited, why not just draw the password? Why we are still relying on the hardware? So think about it. The typing thing comes from the typewriter, which was like what, I don't know, even decades and decades back. And still when we have moved to touchscreen, we are still typing it. Why? We can just draw it. We can use gestures to get authenticated. And this was, I just saw a baby playing the very famous connect the dots. And then it clicked that, why not just do it for web applications? This was that very moment. And then you have Android lock screen. which has its own flaws. So I'll tell you some. Android lock screen, I think it's a 3x3 grid. It's 9 dots. You cannot lift your finger in between. You have to have a smooth motion of the 9 dots, connecting the 9 dots. You cannot connect less than, I think, 3 or 4 dots. 3, I think. And plus you cannot pinch the same dot twice. You just have to pinch it once. And you, I think, cannot lift the finger. So you cannot have 2 parallel lines as a password, which will not work. So that is a fundamental flaw with Android lock screen. And this I take as an incubation of ideas thrive on the fact of realizing its potential and believing in it. So these are very simple things day to day we come across, but it just clicked that why not for web application, and I say Eureka at that very moment. So connect the dots. What are the features and how is it better than an Android lock screen? Possibility of drawing parallel lines. So it simply means you can lift your finger anytime you want. Possibility of clicking the same dot twice. So I say twice means it's 2 and more than 2. You can just click the same dot like 1,000 of times, no problems. Grid scalability as per the touchscreen size. So right now I'll be in the demo, I'll be doing a POC with I think 3x3 grid, but depending on the screen size, you can make it 4x4, 6x6, any kind of dot. So that's very much scalable. And it will rightly come on your web application, so you can have like 10 dots by 10 dots and let people draw whatever they want. And MITM won't work out of the box. This is a major thing. Sniffers will not be able to sniff the actual password. And I'll show you during the demo why is it so, but MITM totally fails. MITM can only work if you can sniff the complete session, not that variable. So you have to sniff right from the first when I open that page to the last when I get authenticated. Then only, yes, you can. But still, it's very difficult. And if you're only looking for parameters, username and password, it will not work. It will absolutely not work. It's easy to remember the pattern, which is very much obvious by now. And endless possibilities, difficult to find meaningful pattern linked to an account. So I have my friends here, Vaibhav, Sohail. If I think what Sohail can draw, I don't even know what he can draw. He can draw a T, he can draw an S, he can draw something funny, I have no idea. With alphanumeric, I would have started at least guessing his name, his surname or anything, but this is way beyond guesses. So these are connect the dot possibilities. These are some funny figures, so my demo is not going to look like that, but anyway, you can put the dots anywhere on screen and let people draw things. That's your password. And you'll remember that, whatever. There's a banana, this is a very complex password actually. This is like some big password. So I'll start the demo. I'll give you a code level walkthrough. This is the grid I'm doing it. So right now you can see the numbers here. So fundamentally how it works is every dot has a number. I have shown it in a picture here. So you just remember 11, 12, 13, 14, 15 to 18, 19 to 22. And once you click on these dots, it's actually at the back 11, 15. This is getting pressed and this is going in the parameter. Okay? And you can, if you press this twice, so it's going to be 11, 11. Similarly, you can press any number of dots, not a problem. Okay, I'll just start the demo. Okay, so this is a login page, and excuse me, there is no security involved here, so this is just a POC. I know some of the parameters you might be seeing in the GET request. Excuse me for that. You can anyways change it to POST request. You can send it over HTTPS. So that's very much acceptable. And I'll start a sign up. Let's say I do a nullcon username and password.
We have to give the password or we have to connect?
I'm just using it as 2FA right now. You can shift it to only grid. So just for a better sake, how it can be used as a 2FA as well. Because the problem is if you're gonna only have graphical passwords and then you end up on a laptop with no touch screen, then it's a pain clicking with mouse. So it's an option. You can either use this password or make it 2FA or just use graphical. So nullcon and password, let it be CONF123. I click submit. So user created successfully, now create a pattern password. So this is the pattern I get. So remember 11, 12, 13, 14, 15, 16, 17, 18, and 22. So let's say I click 11, 12, 13, 14, no, sorry, this is not 14, this would be 14, 15, 16, 17, yeah. So let's say these 4 dots and I register. So there is no visual feedback here. The next demo I'll show, there will be visual feedback as well. So it says pattern captured for user nullcon is 11, 12, 13, 17 and user added to database. Now you can log in here. That's a very simple thing. Now again I do nullcon, I do con 1, 2, 3, I log in. Now what it will do, it will create a session for that user. And it will then ask me to enter my pattern password. I'll show you both the cases. Let's say I do a wrong. These are the 3 and this is the 4th. And let me do it opposite. And send. See, the sniffer actually, if there would have been a sniffer here, it would show you 26, 70, 87, 92, which is absolutely not the password. The decoded values are 17, 13, 12, 11. So this is the opposite I just entered. 11, 12, 13, 17. And it showed it's a wrong password.
So is it sorted or what?
For the sniffer?
Yep.
Okay, I'll come on that. Let me enter a right password as well. So I do a nullcon, con 1, 2, 3. So check session updated. So that was session created. That's one of the clues why it is coming. So if I do this time, now check again. Sniffer says 32, 71, 60, 35, decoded this, correct password, brilliant. So that's the whole idea behind it. I have visual interface also, I'll just follow, but I'll first tell you why it is showing different passwords on the sniffer. I'll do the code walkthrough now. So this is where you get the add grid. So this is where you first put the password, new pattern password. This is very basic HTML and Java stuff. I'll jump down to, so I've used HTML5 canvas here to draw those circles. You can use a simple CSS to draw the square. So my next demo, which is a visual demo, is using a simple CSS. There I'm not using any canvas. So both the options available. And these are just the sizes. The main logic which is going is in the dots. So when you register it, every dot has a value, 11, 12, 13, 14, and the moment you start clicking, it keeps on appending. And at the end, these are all the circles, and at the end, it just gathers them in a counter. This is the ID counter, and in the counter, it adds all those in a serial manner. It becomes like a string, and it sends it. So this is a simple scenario. Why the sniffer doesn't work here? That's when you see this. So this is the database I'm using, or there are 2 tables, session tab and user. User pass, as it's very much obvious, it's a user ID. It's a character password which we first entered, and then the grid password. So grid password is that 11, 15, 16 or whatever, 11, 12, 13, 17, the last one. Now what is session tab? So what I have done is I have linked a session with every time a user gets authenticated on a simple alphanumeric thing. And how it works is it creates random numbers and aligns it as a key to them. So if you can see here, 11 has been made 32, 12 is 71, 13 is 60, and so forth and so on. So every time you refresh the page, new session will be created and new numbers will be allotted. So these numbers will actually go for authentication, the 32, the 71, the 60. Once it comes here, it goes into the database, get the key values of that. So what is 32? It's 11. What is 71? It's 12.
So it's
Then
updated
it
into JavaScript dynamically.
Yeah, so it is a random number, and I'll show you that as well. Let me check this. Let's go. I'll just show you. So what I do is I generate a random number, and then I check whether that random number has been generated before. If yes, generate a new random number. Once it's not being generated, then use that random number for that key, and so the loop goes for each dot. So that's as simple as that. And you end up then having this. So let's, you can see it's 32, 71, 60. And if I come here and I go back to this page, I do a null con, I do conf 1, 2, 3. I log in, it will say session updated. And why it says session updated? Because these values will not now change. So instead of 32, 71, 60, check what it has become now. So now it's 73, 92, 42. So these again all random values. And so anytime you check it on Wireshark or Sniffer, these are random values. So if you will try to replay this 73, 92 in that same sequence, you will not get anything. It will never be authenticated. But as I mentioned, if you are getting the complete session, then first when the page comes to your system, you will get which dot has what value. Then you do a MITM with this, and then you could figure out at the back end that, oh, these are the dots, but not out of the box.
So when you generate a new session, you just compare the numbers with the previous session, right? Not all the previous sessions that you had.
No, so this is a perfectly random number generator. I don't compare with anything. I just randomly keep on generating numbers. And I just compare it that no two dots should have the same number.
Oh, okay.
That would be confusion. So that's the only thing I do. And this, as I mentioned, this, and this is where the registration and everything happens. Now I'll show you the visual based, which is this. Yeah, please.
Did I get this right? I mean, when you use the textual authentication, then using random numbers for each random number is assigned to each and every dot.
Yeah.
Okay, so that assignment is updated to the database.
Yeah.
In one step, and in the next step, when the dots are clicked, then
then those random numbers go.
Is sent to the database.
So random number comes to my application, and my application tags it who's got this 32. So 11 has got this 32. So I have tricked here, instead of going into complexities, what I have done is I have made it into an array. So the keys are that 11, 12, 13, 14, and these are the values. So whenever 32 comes, I check in the array whose value is 32. So it's the 11th element. So suddenly I get that.
So if I select these two pages,
So
the number assignment and as well as the pattern assignment.
So there's no random number assignment on the client side, it's on the server side. So point is JavaScript is there, which is in this page. I'll show you this page. Sorry. So if I do, let me do it. So if I do this, you can see these are the value, 46, 60. So these values have already been given now. So that's why I said to get the complete password, you first need to sniff this page and then the reply, then match both the things. But if your tool is only looking for that what's the password equals to, that value I take, then it's of no use. So you need to get the complete session for it. And if I put it over HTTPS, it's good. That's not possible.
MD5 sorting equivalent of,
No, salting is like, and there's no salting here, there's nothing. Yeah, but so it's kind of obfuscating for the simple tool that way. So these are all the values, and then you start clicking on these circles. So this is now visual interface, and how I have done is, by default, these are the colors of these squares. So there is no canvas here, it's a plain CSS. And this is, any guesses? What is this? Why there is a number and colors? Yes, you're right. So the number of clicks. So point is, in that kind of scenario, if I just put 2 clicks and then somebody calls me, I just like, okay, I forgot how many clicks did I make. So this is just a visual interpretation that if I click it twice, it will change to green. If I click it 3 times, it will change to the 3 color. So similarly, and plus you will remember how many clicks you have made. So let's say I put the same password. So you'll remember that, okay, 111. And then let's say I put again 221. That's my password. So 1 is this, then this. This is the password, and if I click submit now, so it's not going any post request, I'll just throw it. So it's again 11, 12, 13, 17, 11, 12, 16. And similarly, I can send it to my post parameter. So this is where you get a visual feedback. And it can again, so the grid can be expanded depending. So next version, I'll check the screen size using JavaScript, and then I'll make the grid accordingly. And you'll get whole big square grids or circle grids. And then you can eventually have something like this. So this is not in a square fashion, but I can put random dots on a screen, and every time when your username goes, it will show the dots in that manner only so that you can draw your figure. And if some other username comes into picture, it will show dots in some other manner. So that's a future thing, but that can be worked out very easily depending on how username are there. So let's say if a username is A, I'll use 2 by 2 by 3 by 2 by 3, something like that. If a username is B, I'll put it 3 by 2 by 3. So it's all in the database. I can shuffle the dots accordingly. So there's going to be only 25 dots, but the position will change according to the username. So that's future thing, but that is very much possible. So you can have all the drawings. Right now, what is missing is you cannot actually visibly see a line going between these two, because that's HTML5, and excuse me, I'm not that much good in HTML5, so I'll need volunteers if they can help me out. I'll actually visually show you all the lines going on whenever two dots are connected. So having said that, now let us go into not so good points. So what are the not so good points? And yes, do you need any awareness with graphical passwords? You definitely do, because as being with any graphical screen, there are chances of shoulder surfing, and especially when you have a visual feedback. If I'm even standing like 1 meter from you, I can see the pink colors going this, and I'll just keep it. Because whole point is, if you are good in memory with patterns, so does the hacker, because we are good in memory. So yes, you can only use graphical screens. That's why I made it an optional. Whenever you think you are in a secured zone, you do not have any closed circuit video recorder. So most of the corporation these days have closed circuit TV. So next time you type in your graphical passwords, even a security guard who is seeing this video will get to know your password. But that is again with all kind of on-screen keyboard as well. So that's not a big thing. And so does, if you have a good memory, so does the surfer. I can try, this is what I'm trying, but I'm not sure, so I need your response. Will it be good if I try to give a false color feedback? Any comments? Because how I'll do is, if you click this, instead of this color will change. So I can give a false color feedback. If you think that you are very much sure that, okay, these 4 dots I'll click, I can give you a false. So it's something like whenever you will log in, it will ask you, is it a secured zone? If not, it will start giving you false color feedback. So
you can ask the user.
So before, I can.
That may rather confuse the person.
No, that's why I'm asking user if he wants or not.
If I was the user, I would have probably forgotten my password because of the false feedback. I would rather not have a feedback.
So this is again an option.
Yeah, I would rather not have a feedback.
Yeah, then that is already there, so that's not a problem. Or I can let the screen flicker or something for a second. I don't know if that erases a memory or causes amnesia or retrograde amnesia or whatever. I usually see that in Fringe happening. White color erases memory, but okay. So that's work in progress. If I get comments on that field, I'll do that. I can do false colors, I can rotate, I can do whatever, but the user should not be confused because of that, as he mentioned. So moving forward, future roadmap, which is very critical. I am in process of developing a WordPress plugin for enabling graphical passwords for 2-factor authentication, or your choice, for your blog. So this is already in process. I am developing that, and so what at the end, all of your WordPress blogs which are hosted on your websites, you can install this plugin. It will become a wrapper on your existing authentication. So once you put correct graphical password, it will go into the database and send you the actual password and so forth. So your graphical can be an optional for your blog. So this is what I'm doing. Actual lines to show up connecting the dots. HTML5 lovers can buzz me. I'm sorry I spent some time on that, but that's not my cup of tea. So if anyone is good in that, please feel to buzz me. color palette and a grid to fill. And what it means is, this is going to be something like this. There's going to be a grid. It's like a mathematical grid, and you will have a color palette here, which is just like a paintbrush. So you choose a color, pink. You click in this grid, this becomes pink. You choose blue, and this becomes blue. So what at the end you are doing, if you just choose two colors and two squares, what you have done is, first there is color code. So you have used your color code there. Then a square is made up of 4 corners. So there's this 1, 2, 3, 4. So let's say everything has a value of 1 digit, or 1 character. You have used 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So just filling 2 colors in 2 squares, you have made a password 10 character long. And you can easily remember that. So I have developed a demo. I don't have it right now, but I have developed it. It's color palette and a grid to fill, and a closed structure grid to detect simple handwriting. So this is, I'm working with a data analytics person. So what he did is, he tried to put the dots very close to each other. And there are like some hundreds of dots in this square. So at the end, when you even write your signature, so you just write Rishi in a very smooth handwriting, all the dots that are connected. So there's a logical sine curve coming in, sine or cos or whatever. So there's a mathematical computation. So it becomes as if it's a handwriting analysis system, or it's more of a signature analysis system. So the same thing, the dots will be connected, but the dots will be so close to each other that it will look like as if you're just signing your document or signing your web passwords. So this is in planned stage, and the idea is wide open, and I now expect you to show your creativity here, how you can do that. With that, I'll show you something else.
One question.
Yeah, sure.
The point I want to make is like people who are not actually aware of security, or people tend to relax and may choose only this as a password option, and they might choose easy passwords. Like in our Android phones, we tend to choose easy password with a visual feedback.
Yeah.
So that might induce kind of a vulnerability that.
But that's same if you choose the password 123.
Yeah, I mean.
So that's even with alphabets also.
But since it's visual.
Yeah, so that's why I'm not like hitting that. Industry should only move to this, because first of all they are not as much touchscreen devices as we think. So this is optional. All the ones who want their whatever Gmail accounts or something, their personal accounts at least, not to type long passwords, can move to this kind of a password scheme. So this is optional, or better you can work as a 2-factor authentication. So that's anyways more than welcome. Okay, so this is a very small thing. Usually you saw in all the 3 demos, I have two numbers. So it was a number of 2 digits. When I put the value of 11, 12, 13, 14. Somebody asked me that at the end it will count down to a number. Let's say a 25 digits number, but it will be a number. How are you going to put an alphanumeric thing in the same thing? So how I can do that when I click, let's say these are 3 dots. So I put it simple. If I click this dot, instead of a number, an alphanumeric string comes. How I can do that? So there's a demo for this. So let's us assume I have not put dots. These are 3 dots, okay, or 3 squares. And this is the value which is, so I have not put it in a post request, I'll just keep on appending the value whatever comes. So if you click here, it's 1010, click it again, it's 1010, let's click 2. It's 2 dot. So there's an alphanumeric with symbols. You click 3, it's NU, 3, 3, 3, 2, 1. This becomes your password. So check the complexity of this password. And how much time it took me? Just 3 letters, pressing it 5, 6 times, that's it. So you can have a very complex password depending on what you want. So even if I press 111, see the color also changed to show me that I have pressed all this thing, and this is my password. So if somebody is trying to brute force this directly, check this. I have to just remember 111, and he'll have to do a zillion attempts to get to this password. It's the same thing. And if you want to see the code, it's this is the logic. So this is function 1, F1, F2, F3, and these are the values. So you can see value 1010 gets appended every time I press the first one. 2 dot gets appended for the 2, and 3 is NU. So you can have a long number of strings here. You can have anything, conf, and you can have conf, save it, and next time if you're going to refresh it, you press 3 times. So the complexity of the password is huge for a brute force. And if you want to do it on a graphical scale, so I'm planning my next paper on how to hack graphical passwords. So I'll tell you how to actually hack this kind of a password with not a straightforward thinking. It's coming the other way around. You have to first understand the grid. You have to first understand the drawing concept. Then you can run a brute force thinking that these are dots, not just plain. So take it this way. This is a single dot. So even for a single dot, I'll have to run a million attempts. So, but if I get the value of each dot first and then put it in a database and use that database to brute force, then it's going to be look like as if I have each value of these 9 digits, 9 whatever, circles. So, which is again for the future. I'll write a paper on that. But I think that's pretty much done. And if you have any questions on the code, if you have any questions on the future development or any confusion. Yep.
So how do you suggest developers should use this? The user logs in, types his username, and then he has a choice of either putting in a text password or
a graphical path, yeah. And that is one of the options, or I just mentioned you can use it as a 2-factor. So first he enters that password, then comes the grid. So most of the banks these days are, once you enter your alpha password, alpha numeric password, after that they give you a set of pictures to choose or something. So that is their 2-factor. Or they send you a code on your mobile phone. This also can be a 2-factor. So
well, it's not 2-factoring like in the terms of 2-factor, because 2-factor is something you have and something that you know. So
yeah.
these both things are something that you know, it's not something you have. It's just like
yes, that's yeah. Actual 2-factor, it's not. In that case, you'll have to have something key or your mobile phone or something. But that's what banks do. I asked 2 banks that the same I told you about pictures. They said no, sir. This is our 2-factor. I said okay, fine. So that's that kind of stuff.